Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. On today's video tutorial, we are still going through the grade 12 mathematics paper 1 that was written in June 2021. On today's video tutorial, we are going to be focusing on question 3, and question 3 covers geometric series. Before we get started with the video tutorial, please make sure that you are subscribed to the channel. Please make sure that you share the channel with your friends that are doing mathematics, and please also make sure that you give this video a huge thumbs up so that we help the channel grow and reach more learners that are struggling with mathematics or learners that want to better their mathematics. Okay guys, so without any further ado, let's get started with the video tutorial. Okay, question 3. Like I mentioned, guys, this question covers geometric series. All right, so let's get started. 3.1. If R is equal to 1 over 5 and A is equal to 2000, right? Question 3.1.1 asks us to determine the general term of the series. Okay. So they want you to just determine the formula for the general term of this series, okay? So guys, from here, we know that when you're working with a geometric series, what is that standard formula that you're supposed to substitute your value of your A, your value of your R, and your N into, right? The standard formula that we use is Tn, which is equal to AR to the power of N minus 1. Okay, so this is the formula that you use when you're working with a geometric sequence or a geometric series, right? So, but then yeah, they made our lives very simple because they already gave us the value of your A. So you're just simply going to substitute the value of your A, which is 2000, okay? And your value of your R, which is 1 over 5. And you're going to be left with the N minus 1. So you substitute the value of the A, which is 2000, the value of your R, which is 1 over 5, right, to the power of N minus 1. So the general term of the series is represented by Tn, which is equal to 2000, open bracket, 1 over 5 to the power of N minus 1. Okay, so the next question is we need to basically find the value of our term 7, right? So we're basically going to substitute 7 where we see N to find what the value of our term 7 is, right? So we're going to put our equation that we used, the formula for the nth term of this geometric series, and we found it to be Tn, which is equal to 2000 multiplied by 1 over 5 all over N minus 1, right? And we want to find what term 7 of this series is equal to. So where we've got N, we're going to substitute 7. So it's 2000, 1 over 5 to the power of 7 minus 1. Okay, and then you're just going to punch that into your calculator. So we found that term 7 is equal to 16 over 128. Okay, but we're going to focus on this one. So our term 7 is equal to 16 over 128. Next question, which term of the series will have a value of 16 over 15,625? Okay, so what are we looking for here, right? So we want to first start off with the general term, with the general formula for the nth term of our series, right? So the general formula for the nth term of our series was Tn, which is equal to 2000 times 1 over 5 to the power of N minus 1, right? And they want to find out which term of this series will have the value of 16 over 15,625. So this is what? This is our Tn. We are given the Tn because we are given the value of that term, and we just want to determine the position of this value, the position of this value, right? So we're given Tn, so this is our Tn, okay? And we want to determine the N. We substitute this value into this formula. So we substitute this value into this formula, and we solve this equation for n. Okay, so we solve for n. Okay, so you're gonna have 16 over 15,625, which is equal to 2,001 over 5 to the power of n minus 1. Okay, so guys, this question requires you to basically know your logarithm laws or your exponential laws, right? So if you haven't watched the video that I've created for you guys where I've went through exponential laws, guys, please have a look at that video because it will always come in handy. Exponential laws always come in handy when you're working with a geometric sequence or geometric series, right? So it is very important for you guys to know how to solve your exponential equations. Solving exponential equations helps you solve geometric series, especially if you have to calculate the value of n. So guys, please make sure that you watch that video on the exponential laws, right? Okay, so let's get started. Let's solve this, right? So what we're going to do is we're going to divide by the 2000, so we get rid of the 2000 on the right hand side. So you're going to divide by 2000, divide by 2000. Okay, and you're also going to divide by 2000 on this side. Okay, so when we divide by 2000, right, the 2000 cancels here. Okay, and you're going to be left with 16 over 15,625 divided by 2000, which is equal to 1 over 5 all raised to the power of n minus 1. Okay, so 16 over 15625 divided by 2000 is equal to, I'm going to leave it as a fraction. It's going to be 1 over 1953125, which is equal to 1 over 5 to the power of n minus 1. Okay, so from here we've got 1 over 1953125, which is equal to 1 over 5 all raised to the power of n minus 1, right? So guys, for me, I want to basically get rid of this fraction because it just makes my life a bit complicated, right? So I want to get rid of these fractions, right? So that I can see what is going on. Okay, so how do we get rid of these fractions? Let's just have a look at what is going on here on the right. Okay, so basically 1 over 5. So 1 will be raised to the power of n minus 1. And the 5 will also be raised to the power of n minus 1. Okay. And then guys, do we agree? 1 raised to the power of anything will always be 1. Okay. So we can leave that as 1 all over 5 to the power of n minus 1. Right? If you take 1 and you raise it to the power of 2, you get 1. If you take 1, you raise it to the power of 3, you get 1. Okay, 1 raised to the power of 2 is 1. 1 raised to the power of negative 3 is still 1. 1 raised to the power of 4 is still 1. 1 raised to the power of 1,000, it's still 1, right? So 1 raised to the power of anything is always going to be 1. Hence, that is why I've basically left that one out, because 1 raised to the power of anything will always be 1. And you're going to be left with 5 to the power of n minus 1. Okay, so I'm going to put that there. So it's 1 all over 1953125, which is equal to 1 over 5 raised to the power of n minus 1. Okay, and then from here, guys, do you guys agree that we can just simply, okay, swap this around? So we can just say 1953125 is equal to 5 to the power of n minus 1. Okay, because I've multiplied if you swap this on the left hand side, then you must swap on the right hand side, because you don't really change your equation much, because you swapped it on the left hand side, we can swap it on the right hand side, right? And then you're gonna have 1953125, which is equal to 5 to the power of n minus 1, right? Okay, and then from here, if you actually thinking about exponential laws, you can think that, okay, we need to have the same bases on the either side, right? So you have to have the same base of 5 on the left hand side and the same base of 5 on the right hand side for you to be able to just bring down the exponents and solve for n, right? So let's see if we can get the same base of 5 on the left hand side. Okay, so if you take 5 to the power of 9, right, Just take your calculator and check. 5 to the power of 9 is equal to 1953125, right? And then from here, guys, what do we see? We see that we have the same bases, okay, on the left hand side and the right hand side, the same base of 5 on the left hand side and on the right hand side. And from here, you can simply drop your exponents, and you're going to have 9, which is equal to n minus 1. And you can just simply solve for n, right? And when you solve for n, okay, when you solve for n and you move the negative 1 to the left hand side, it's going to be 9 plus 1 is equal to n. Therefore, your n is equal to 10. Okay, question 3.2. Consider the geometric series where we are told that the sum of this series from n, which is equal to 1, to n, which is equal to infinity, is equal to 27. And also the sum of 3 terms in this geometric series is equal to 27. Okay, so we need to calculate the value of the constant ratio of this series. So we've got a series, right? And it's a geometric series. Okay, and we need to determine what the constant ratio is for this geometric series, right? So when you're working with geometric series, guys, this is just additional notes. There are 3 equations that you guys always need to remember. So the first one is the sum to infinity is a over 1 minus r. Okay, the other formula that you need to remember is this Sn is equal to a r to the power of n minus all over r minus 1. And this formula, we usually apply it, right, if you want to get the sum of a geometric series and you're given a constant ratio which is greater than 1. And the other formula that you guys need to remember when you're working with a geometric series is that a open bracket 1 minus r to the power of n all over 1 minus r. And this one is applicable if you're given a geometric series and you're given that the constant ratio is probably less than 1. So these are the 3 important equations that you guys really need to have at the back of your heads when you're working with a geometric series, right? But then in this case, we are told that, okay, we've got an infinite geometric series, right? Because we are given this information here. It's an infinite geometric series, and the sum of that infinite geometric series is equal to 27. So we're given S infinity, and S infinity is equal to 27. Right? And we're also given Sn, okay? We're also given Sn. And we are told that Sn, okay, or S3, okay, is equal to 26, right? So we basically need to work with these equations to help us calculate the value of our constant ratio. How are we going to work with these equations to help us calculate the value of our constant ratio, right? So we already know that we are definitely, most definitely, working with this equation because we know that the sum of a geometric series that goes on to infinity is given by that formula, right? And then for the next step, where we are going to substitute the value of S3, which is equal to 26, we can either use this equation, or we can use this equation, right? So it's up to you. Why am I saying we can use this equation or this equation? Because we don't know what the value of r is. We are really not limited on which equation we can use between these two. Okay, so I'm going to use this equation, right? And we're going to work with these 2 equations to get what our value of r is. Okay, so let's get started. Let us substitute all the values we are given into these equations, and let's start and calculate the value of our r. Okay, so starting off with the first equation that I said we're going to use, right? So I said that S infinity is equal to a over 1 minus r, right? And I also said the other equation that we are going to use is Sn, which is equal to a 1 minus r to the power of n all over 1 minus r. Okay, so we were told that our S infinity is equal to 27, and we were told that our S3 is equal to 26, right? So we're going to substitute these values. So it's going to be 27, which is equal to a. We don't know what our a is, and we also don't know what our r is. We're going to leave the equation like that. Let's look at the next equation. Okay, so we know that Sn, the sum of 3 terms in the series, is 26. So we're going to put that 26 there. We don't know what our a is, so we're going to put the a, 1 minus r. What is our n? We know that our n is equal to 3. We're going to put the 3 there, right? All over 1 minus r. And then what are we going to do with these two equations? We've got an equation on the left and we also have an equation on the right. How is these two equations going to help us get the value for our A? Do you guys realize that if we make A the subject of the formula for both these equations, we are going to be able to cancel the A out when we substitute these two equations together, and we will be able to get the value of your R. Okay, so let us make A the subject of the formula. So it's going to be 27 multiplied by 1 minus R is equal to A, right? So I'm going to call this our equation 1, okay? And then let's look at the right-hand side, right? We want to make A the subject of the formula, so it's going to be 26, okay? You're going to multiply it by 1 over R, and you're going to divide by 1 minus R to the power of 3, so that it cancels and it goes to the other side. So you're going to also multiply this side by 1 minus R all over 1 minus R to the power of 3. Okay. So if you multiply by that, we see that that will cancel on the side, right? And you'll be left with, okay, 26 multiplied by 1 minus R all over 1 minus R to the power of 3, and you're going to be left with the A on this side. And we are going to call this your equation 2, right? And then from here, guys, do you agree that if we substitute equation 1 into equation 2, right? So if we substitute equation 1 into equation 2, we will be getting rid of the A, and we will be able to start solving for your R. Okay, substitute equation 1 into equation 2. So it's going to be 27, 1 minus R is equal to 26, 1 minus R all over 1 minus R to the power of 3. Okay, and then from here, guys, do you see that we can just simply divide by 1 over R on the left-hand side, right? So if we divide by 1 over R on the left-hand side, right? And that what you do on your left-hand side, you do on your right-hand side. Do you see that we'll be able to cancel this 1 over 1 minus R on the right-hand side? Okay, so that is exactly what we're going to be doing. I'm going to do it in red. So you're going to divide by 1 minus R, okay? And you also divide by 1 minus R. And if you divide by this 1 minus R, right? Do you see that the 1 minus R cancels on this side and the 1 minus R cancels there, right? It cancels, right? And then we'll be left with 27, which is equal to 26 over 1 minus R cubed. 1 minus R cubed. Okay? And then from here, guys, we can just simply multiply by that. Multiply by 1 minus R to the power of 3, multiplied by 1 minus R to the power of 3, right? And if you multiply by 1 to the power of minus 3, that cancels on this side. Okay? And you'll be left with 1 minus R to the power of 3 multiplied by 27, which is equal to 26, right? And if I divide by the 27, okay, divide by 27, right? You'll be left with 1 minus R to the power of 3 is equal to 26 all over 27. And then you just simply solve for your R to the power of 3, okay? So I'm going to make this simple by just taking it to that side, okay? So it's going to be 1, and then take that to the other side, minus 26 over 27 is equal to R to the power of 3. Okay, and then we simply put that into your calculator like that. The cube root of 1 minus 26 over 27 to get your value of your R. Type that into your calculator. 1 minus 26 over 27. And if you really type that into the calculator like that, you'll find that your value of your R is equal to 1 over 3. Okay, let's just quickly go through what we did in this question because it's very, very important. Okay, from this question, guys, we saw that we were given an infinite geometric series, the sum of this infinite geometric series, and we are told that the sum of this infinite geometric series was 27, right? So then we look and we think, okay, what is the formula that you use when you're working with the sum of an infinite geometric series, right? And the formula that you're given, right, in your formula sheet that works with the sum of an infinite geometric series is equal to S infinity, right? Which is equal to A over 1 minus R, right? So that's the first formula. Then, what other formula do you guys have to know when you're working with a geometric series? Because we're also told that the sum of 3 terms in this geometric series is equal to 26, right? So, the other two formulas that you're given is this one and this one, right? And then, we can see that if we were to just substitute this equation into that equation, putting in the values that we have been given, right? We will be able to basically, right, cancel out the A and solve for R, right? So I took the S infinity, which is equal to A over 1 minus R equation, and this equation, which is Sn, which is equal to A, open bracket 1 minus R to the power of N over 1 minus R, okay? To basically help me calculate the value of R. If you wanted to use this equation, you could do that, right? Because you're really not restricted on which equation you can use between these two, right? Because we are still trying to get the value of your R. So if you wanted to use this one, you could use this one. If you wanted to use this equation as the second equation, you can also use that one, okay? Right? So I substituted our S infinity is equal to 27 into the equation S infinity, which is equal to A over 1 minus R. And I also substituted the S, which is equal to 3, S3, which is equal to 26, into this equation, right? And we found that our equation 1 was 27, open bracket 1 minus R, which is equal to A. If you make A your subject of the formula as our equation 1. And we found that 26 open bracket 1 minus R all over 1 minus R cubed is the second equation if you make A the subject of the formula. And we saw that if we substituted these two equations into each other, we will be able to basically cancel out the A and be able to solve for the R. And we found that the value of our R was basically equal to 1 over 3. Okay, guys, so we are done. We were able to calculate the value of the constant ratio R of the series. Okay, so that is it for today's video tutorial where we went through question 3 of the grade 12 mathematics paper 1 that was written in June 2021. Please make sure that you are subscribed to the channel. I will be going through question 4 of this paper, guys. I'm taking you guys through the whole paper. We're going to go through paper 1, we're going to go through paper 2, we're going to go through every single topic that you guys need to know to help you prepare for your June exam. So please make sure that you are subscribed to this channel because we are here to learn, we are here to pass, and I'm going to make sure that you guys pass, right? Question 4, we are going to be going through functions, right? So please make sure that hit the notification bell so that you get notified every time I upload a new video. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.